For centuries, humanity has looked up at the night sky, asking one question: are we alone? Every telescope, every mission, every sleepless night under the stars has been driven by that simple thought. And now, for the first time in history, we may finally have an answer. NASA's James Webb Space Telescope has just detected something extraordinary, something that could change everything we believe about life in the universe. Around 120 light-years away, in the constellation Leo, there orbits a world known as K2-18b. When the James Webb Telescope turned its golden mirrors toward this distant planet, it captured a faint flicker of starlight, light that had traveled across space for more than a century before reaching us. Hidden within that light was a signal, a chemical fingerprint that stopped scientists cold. It showed traces of a molecule called dimethyl sulfide, or DMS, a gas that on Earth is only produced by living organisms, not by volcanoes, not by chemistry alone, but by life. The data shows a 99.7% confidence level. In scientific terms, that's nearly certain. If confirmed, this would be the first ever detection of a true biosignature gas on an exoplanet, the first whisper that something alive may be breathing beyond our solar system. K2-18b orbits a small, cool red dwarf star. It's about 8 times the mass of Earth and sits in what astronomers call the habitable zone, the region where temperatures might allow liquid water to exist. It's not a rocky world like ours, but something different, a Hycean world, a planet with both a hydrogen-rich atmosphere and a vast global ocean below. Imagine a deep, endless sea wrapped in layers of glowing gas, illuminated by the dim crimson light of its star. When Webb observed this planet passing in front of its sun, the starlight filtered through its atmosphere. By breaking down that light, scientists identified the telltale chemical patterns of water vapor, methane, carbon dioxide, and DMS, the molecule that, on Earth, drifts from ocean plankton as a byproduct of life. The implication is breathtaking. On a distant planet orbiting a red dwarf, something may be alive, exhaling that same chemical signature across the void. But science is just the beginning. To truly understand what this means, we have to imagine what such a world might look like. Picture descending through the clouds of K2-18b. The sky isn't blue, it's crimson, tinted by the light of a red sun. The air is thick, heavy, filled with hydrogen and mist. Lightning flashes in slow motion through towering clouds that stretch for miles. Below, the clouds part, revealing an ocean that stretches endlessly in every direction, glowing faintly under the red light like molten glass. The waves rise and fall in slow, heavy rhythm, sculpted by stronger gravity. The wind hums across the surface, carrying a faint shimmer, the microscopic life that might be creating those DMS molecules. The water is dense, metallic, and warm, kept liquid by the pressure of the atmosphere. Beneath the surface, sunlight fades quickly, replaced by a soft blue-green glow. There, in the darkness, life stirs. Imagine translucent creatures drifting through the depths, jelly-like beings that pulse gently with light. Their bodies are delicate, almost invisible, shaped not by bones, but by chemistry. They feed on nutrients rising from the ocean floor, converting energy from faint sunlight and minerals into motion, color, and sound. Around them swarm clouds of microscopic organisms, alien plankton, floating in glittering trails, releasing dimethyl sulfide just as Earth's plankton do. Far below, volcanic vents crack open the seafloor, releasing heat and minerals into the water. Around those vents grow forests of crystalline stalks, plant-like forms that shimmer with iridescent hues, drawing energy from the chemical reactions between water and rock. Tiny creatures move among them, glowing softly in the dark, like fireflies trapped underwater. And above all this, vast, manta-like beings glide gracefully through the deep. Immense, slow-moving creatures that convert faint starlight into energy through thin, transparent membranes. Their bodies reflect the crimson glow of their world, their shadows sweeping across the ocean floor like drifting clouds. It's a world of perpetual twilight, an ocean planet alive with light and motion. The air, though toxic to us, would shimmer with moisture and faint bioluminescent particles. Every breeze might carry traces of that same DMS Webb detected, the breath of life on another world. Now, imagine time flowing forward, millions of years. Life evolves. The microscopic becomes complex. Communication begins, not with sound, but with light. Flashes and patterns move through the ocean like messages, connecting creatures across vast distances. A neural network of living organisms emerges, not individual beings, but an entire ocean thinking as one. A planetary mind made of bioluminescence and chemistry. To such a world, the red sun above would be more than light, it would be rhythm. And one day, when our telescope's faint golden reflection appeared in its sky, maybe that world noticed. Maybe somewhere in those living waves, a pulse of light flickered back, an instinctive response from one form of life to another, separated by 120 light years. For now, these ideas live in the space between science and imagination. We can't yet know if the DMS Webb found truly came from living beings. It will take years of data, countless tests, and perhaps future missions to confirm. But the fact that this is even possible, that we can read the chemistry of a planet's sky and see hints of life, changes everything. Because this discovery isn't just about one planet. It's about what it tells us of the universe itself. If life can emerge on a world like K218b, with its hydrogen skies, its red twilight oceans, its endless storms, then life is not rare. It's inevitable. It's a force woven into the fabric of the cosmos. Wherever there is warmth, water, and time, life will find a way to exist. Think about that. Every star you see in the night sky may have its own worlds, each one potentially carrying oceans, clouds, continents, and maybe even beings looking up at their own alien heavens, wondering if they're alone, just as we once did. The James Webb Telescope wasn't designed to find aliens. It was built to look back in time, to witness the birth of galaxies and stars. But in doing so, it may have stumbled upon something even greater, the living present of another world. Each photon Webb collects carries a message, a fragment of light that began its journey before any human alive today was born. And now, that light whispers to us across the darkness. Life might not be the exception, it might be the rule. So as we stand here, looking up at the same sky, we're not just seeing stars, we're seeing possibilities. Oceans beneath crimson suns, planets breathing invisible air, worlds waiting to be known. K218b may be the first, but it won't be the last. The James Webb Telescope has opened a new era, a window into the living universe. And somewhere out there, perhaps another civilization has done the same, turning their eyes toward our tiny blue dot, asking the same ancient question. If one day, across the endless ocean of space, we could send them a message, it might be simple. We saw your light. Because in that moment, across 120 light years, two worlds would know each other existed. Two sparks of life, separated by distance, but connected by curiosity. And maybe that's what the universe has been waiting for. Not for us to find life, but to recognize that the act of searching for it is life itself.
This is K2-18b, a whisper across space, a promise written in starlight, and perhaps the first true sign that the universe might be alive.